Hello friends, welcome back to Program with Akshay, and this video is the continuation of the previous part. In the previous part we had seen like what is Docker, what are the benefits of Docker, why we are using Docker, what is Kubernetes, why we are using Kubernetes, and the architecture of Kubernetes. Also we had created a sample WebAPI application using entity framework core, and we have created the customer controller, we have created the customer details, services, the repository, we have added a seed data class, and we have added the dp context. Okay, so in this video, this video is the continuation of the previous video. So basically we will in this video we will create a docker file, we will create a deployment.yaml file, and we will create a service file. Okay, so the agenda or the goal for the today's video is basically first we will create a new docker file. Let me take my pen. Yeah, so first we will create a docker file. Second, we create a deployment file to deploy our code in Kubernetes. And third, we will create a service.yaml file to communicate our deployment and the Docker files. So service file is basically you can use how to orchestrate the containers. Okay, because we have created a Docker file, we will create a deployment file. In the deployment file, we will create those YAML file code, and the service file is basically it tells the container on which service, on which port it is going to run. Okay, so we will see all those details in shortly. Now, first and foremost, let's create a new Docker file. Let's create a new Docker file, add item, Docker file. The Docker file doesn't have an extension. Yes, okay. Now to speed up things, I have already created the code for the Docker file. And this code is already been explained in my previous videos. So you can refer my previous videos, what exactly this terminology like from mcr.microsoft.com.net SDK 7.0, what the copy is doing, then how the run command is executed, then how we are exposing the port on which the port we are going to run the image and run the application, and then the entry point of the application. So basically all these steps are being explained in the previous videos. Okay, so like I will not going to explain the same steps again. You can watch the previous videos. Okay, so we will create a deployment.yaml file. Okay, now let's create a deployment.yaml file, new item, say it as deployment.yaml, and remove the cs. Yes, so the YAML file will get created. Now yeah, so to speed things up, I have created a YAML file, I have created a service file. Okay, so I will push this code into the GitHub so you can have a look on the code. Okay, so I have created deployment.yaml file for Kubernetes, and we have something called as API version, where API version is our version 1. We have something called as kind. Okay, so kind can be deployment, can be service, that can be object. Now inside that we have something called as metadata. Metadata is nothing but you have to give a name to that particular object or to your particular metadata. Like you can give any name like demo hyphen app deployment or any name. Okay, so but that name should make sense once you deploy the code. Okay, then inside that we have something called as specs. Specs are nothing but a specifications. Okay, now how many replicas are required for your pods? Okay, there can be one, there can be two, there can be three, and so on and so forth. So if one replica is down, another replica can be up. Okay, then inside that specs we have something called as selectors, and inside the selectors we have a property called as match labels. So match labels are nothing but we have to give a name which has an app property, and app has nothing but a customer hyphen app. So those are nothing but a label selector to match the pods controlled by this deployment, which means if you create a service.yaml file in your project, inside that the name of that match labels should be the same of the name of the deployment.yaml file. In that way the deployment.yaml file will be able to communicate with the service.yaml file. Okay, now the template, inside the template, the labels, all the labels should be the same, which you are going to create in service.yaml file. Again, we have something called a spec. So that is nothing but a specification where you have to give a container name, where you have to give an image name, and this image pull policy is nothing but an advanced concept in Kubernetes. Let me know in the comment section if you wanted to know about more advanced sections on Kubernetes. And then you have to specify the ports. Okay, after specifying the ports, then you have to expose the port in the AWS where you are hosting the application. Okay, so this is nothing but a deployment YAML file which will deploy our application in the orchestrator in the container. Okay, now we have something called a service.yaml file. Okay, so inside the service.yaml file we have API version. Okay, that specifies the version of the service resource. Then we have something called as kind. Okay, here now we are creating service.yaml file, so our kind will be service. Here in deployment file, the kind was deployment. Now we have something called as metadata that contains the metadata of services, including the name. We have inside the name, it is called as customer hyphen app hyphen service. Okay, then specs is nothing but describe the desired state of the service. Okay, selectors are nothing but which defines a label selector that selects the fruit to be displayed by the service. Okay, in this our case, the selector name is customer hyphen app, and here the name is customer hyphen app. Make a note that this name should be the same. Okay, then there are ports. Okay, the port is 80, then the protocol is TCP, and the target port is 80. Okay, and type is nothing but the node port. Okay, like it is the type of service like where we are using load balancer, and like the cluster IPs and so on and so forth. Okay, so we have created the deployment file, we have created the service file. Now let's do the repository. Like let's code push our GitHub repository. Let's create our AWS EC2 instance, and after creating the EC2 instance we will create a new folder, and after creating the new folder we will clone the repository, and after cloning the repository we will build the Docker image, and after building the Docker image we will apply those deployment and service.yaml file, and our application, our API will be hosted on our AWS EC2 instance. So let's start. I will push this code to our GitHub repository first. Yeah, there are no active repositories. Good. Yes. And we have something called as, yeah, correct. Make it as public, and create and push, save, and our code will get pushed to GitHub. That will be great. Now, meanwhile, let's log in into our AWS account. AWS console. Login back. So yes, after logging into EC2 console, we will create a new server, an Ubuntu server, and let's create a new server. Let's create a launch instance. After creating a launch instance, we will ks demo. We will select an Ubuntu image. For this server, we are going to select an instance type T2 large. Yes, so T2 large, or you can select T2 extra large. Yes. So why you need a T2 large instance type? So basically to run Kubernetes, to run minikube, to run kubectl, to create pods, you need minimum of 2 cores, okay, on a server. So that is why we need to have a T2 large. After creating a demo, you can terminate that instance so that you will not get charged. You can either select T2 large or T2 x2 large. Okay. In my case, I will select T2 x2 large, or you can select T2 large. Select the key value pair or the key pair. Select, yeah, allow HTTPS, allow HTTP, and that we go. This will launch our instance. Let's wait for a minute here now. So after launching an instance, we will run some commands where we are going to install Docker, where we are going to install Kubernetes, where we are going to configure kubectl with the help of curl command. We will going to install that. So I already have those set up handy, where we are going to install our Docker, where we are creating a user group and assigning those permissions to that user. Okay, where we are to install minikube and kubectl, we are going to use this curl command, and then we are going to install kubectl, and we are going to start the Docker image. So these are the steps we will run. So once the setup is ready, we will connect. Let's connect. So our server is up and ready, and I simply will copy paste this. First we are going to update our server, then we are going to install the Docker packages, then we are going to assign the Docker permission to the Docker user, and we are going to create a new user group called as Docker. Okay, so let's clear this and let's just paste this, and there we go. This will install all the libraries and all the Docker images, all the packages. So let's wait. Yeah, and let's copy this curl command. So this curl command is nothing but our minikube installation. Yes, so our update command is ready. Our Docker packages are ready. Now I will copy paste this curl command to install the minikube, and our minikube installation is done. Now I will configure the Linux AMD 64 and move into user slash local slash bin slash minikube. So basically I'm going to install the minikube Linux 64 libraries and inside this folder. So this is done. Now I am going to sudo snap install kubectl classic, going to install kubectl. This will install the kubectl classic. This will take some time, and this is canonical installed, and then there you go. So this will install all the drivers which are related to Docker, related to minikube. This will set up the cluster for the minikube. This will set up the, if you see the Docker PS command, or if you run the Docker PS command, what are the Docker images are there right now? You can see a minikube Docker images already running. So basically this will install all the packages, all the clusters which are required to set up the Kubernetes. So this is the command for that. Let's wait for a minute again. You can see creating Docker containers, which has 2 CPUs, and this is the memory. Yeah. So we are able to start our Docker. Now, if you see Docker PS, you can see the Docker image or the Docker container is already running, and we have the image name, so something called as K8s-minikube. So basically once you run this command, minikube start -- driver is equal to Docker, this will create an image inside our server that will execute the Docker image for the Kubernetes, and it will run inside that container. So our minikube container is ready. Okay, now the next step is we are going to create a folder, and inside the folder we are going to clone our repository from GitHub, and after cloning the repository will try to build the image. After building the image, we will try to push the image to Docker app. So the flow of the is where we have already created .NET application in our previous video. Yeah, and we have already pushed our code to GitHub repository, where we have created our Docker file, service file, and deployment file. After pushing the code to GitHub, we had already created an EC2 instance where we created all the libraries and dependencies such as Docker packages and minikube. Now, after creating an EC2 instance, we will build the Docker file we will push the image to Docker Hub. So right now we will do all the steps. So let's do it. We will go here and we will simply create a new folder, mkdir projects, cd projects. Now we are inside our projects folder. Now let's go to our application on GitHub. Let's copy this and let's try to clone it. So git clone, this will clone our repository. This will take us 2 seconds. Now to an ls which has web API. Let's go inside the folder cd web. Now let's again do ls. So there we go. So we have something called as Docker file. We have deployment.yaml file and we have service.yaml file. Now let's try to build a Docker image. So to build the Docker image, we have some command called as docker build -t -k /web -api dot. So this will build the Docker image and we can see the Docker image. To see the Docker images which are built inside our server, the command is docker images. So we have something called as image name as /web -api. Tag is latest. This is the image ID which created 4 seconds ago, and this is the image size. Now we are going to push this image to Docker Hub. So first we will log in into Docker Hub from server. Login succeeded because I already have the credentials for username and password. Now we are going to try to push the Docker image. So the command is docker push and our image name here is /web -api. Sorry, Akshay Fadke. So Akshay Fadke is nothing but my username, and this will push the image to our Docker Hub. So we are already created the .NET application in the previous video. We had pushed the image to our GitHub repository. We had cloned the application to our server. We created our EC2 server where we have selected the instance type as T2 large or TX2 large. Now we have already installed the binaries, the already packages for kubectl and Docker. We clone the repository for our web API application. We built our Docker image and we pushed our Docker image. Now what we are going to do is, like, if you see the Docker PS, we already have the kubectl container running, but we don't have our web application container running. Now we are going to try to create a prod where we have created our deployment file, where we have created the service file, where we are going to apply this deployment file and apply this service file, and we are going to create those replica for those pods, and where we are going to see the auto healing and auto scaling. Okay, now let's try to apply and let's try to see the all other steps. So we have something called as deployment.yaml file. Now we are going to apply this deployment.yaml file. So to apply, we have command kubectl-f apply deployment.yaml file, kubectl apply -f deployment.yaml. So our deployment is being created. To see the deployments, we have command kubectl get deployments. Now we are customer app is up deployment 2/2 is ready. Okay, because we have set the replicas as 2. Okay, so that is why 2/2 is ready. Now we are going to apply the service file. So to apply the service file, the command is kubectl apply -f service.yaml. So our service has been created. Now to view the services, we have command called as kube get services. So this is the service, the name of the service, which is the type is node port. This is the cluster IP and these are the ports. Okay, which is being created 7 seconds ago. Good. So if you see kubectl get nodes, get nodes, kubectl get pods. As you can see, our pods are up and running. Okay, and we can see there are two pods right now because we have created the replicas as two. If you wanted to make more replicas, that means 4, 10, and or 20, you can edit the deployment.yaml file, and inside the deployment.yaml file we have something called as replica, and inside the replica we can update the replica and update as 4. So once you update the replicas as 4, it will automatically scale the number of pods. Okay, so that means instead of 2, the number of pods will be 4. So this is where we can do the auto scaling of the application. Okay, and if you try to delete this pod, it will automatically heal the pod with a new GUID ID. Okay, so that is nothing but an auto healing. So if suppose any DevOps engineer or any developer try to delete the pod by mistake, the Kubernetes has a feature something called as auto healing. It will auto heal the pod and with a new GUID ID, and automatically the pod will be up and running. So this is the feature of Kubernetes where we can auto scale the application with the number of replicas, or we can auto heal the application, auto heal the pod. So that means that our application availability is up and running most of the time. So our application is created inside our application is cloned to inside the server. The pods are up and running inside our server. Now we wanted to expose this service to an external world or to our browser. To do that, we have to get the URL first. Like suppose minikube, the command is minikube service, the service name hyphen URL. Okay, so we will get the URL. Okay, if you try to run this curl hyphen L and copy paste this, and if we don't get any error, that means our application is good. Curl hyphen L, yes, hyphen L. Yeah, we don't get any error. That means our application is good. Now we wanted to expose this service to a browser or to outside our environment. Okay, to do that, we have a command called as expose, where we are going to expose our service. So the command is kubectl expose. What should we expose? The deployment we should expose. So our deployment name here is container hyphen app slash deployment. Okay, so here we are going to do the expose, where we are going to expose. Okay, so what we should expose? So expose is nothing but our deployment. So here in case our deployment is customer hyphen app slash deployment and type is node port. So let's enter this. So the deployment service slash customer hyphen app hyphen deployment is exposed. Now we have to run on a specific port. Okay, now we have to do a port forwarding in that case. Okay, so port forwarding, for the command, the port forwarding is kubectl port hyphen forward service, and in this case our service name is customer hyphen app slash service. If you see here, our service name on 8080, and the target port is 80 slash hyphen address, and this is the local host. Why 8080? Now let me explain this. Yeah, so basically we are creating number of pods. So in our case, we have pod 1, pod 2, pod 3, and so on and so forth. Okay, so basically to expose this whole container, okay, to expose this whole service, we are going to bundle this inside one container, and we will try to we will try to give the port as 8080, because these pods are already running inside the container, because this pod certainly has an IP address and a port number. So all these pods are running into 8080. So we are going to combine all these pods on 8080 port with the help of our IP address. So once you try to expose the port on 8080, you can see with the help of your public address, and you give the port as 8080, you can run your service of your web application. So that is why the 8080 port is used. So basically to combine all the pods inside one container or inside a one structure, and to expose to a particular port rather than exposing to an 8080 port, because all the pods are running into 8080. If we select the port as 8080, we can select only, or we can expose only one particular pod to an external environment. But we don't want it to do that. We wanted to expose all the pods which are there inside the cluster. Okay, so that is why the port 8080 comes into play. Okay, so let's do it. So the command is kubectl port -forward service slash the service name 8080, and there we go. So before doing that, first we need to go to our security groups and we need to enable our 8080 port. So let's do that. Go to EC2 instance, and inside the EC2 instance, go to port 8080, select the server, select the security, edit the security groups. Then we need to edit the inbound rules and add an inbound rule saying that we need to enable the port 8080 from anywhere. And there we go. Save rule and go back to our instance connect and just simply run the application. So the port forwarding is forwarded to our 8080. Now let's try to browse our application. Go to EC2 instance and select the server, the public IP, select the port 8080 slash swagger slash what was our index.html, right? And there you go. Our Swagger API or our web API is up and running. Let's try to get the application. Let's try it out. Execute. And we have something called as Akshay. Okay. If you see in our seed class, we have data like Akshay Dombivli. The customer number is 1234 and pin code. So yes, our CRUD operation is successful. We can do the get, put, delete, and so on and so forth, get by ID, and we have created the Docker image, and we have created the cluster in Kubernetes where we have seen the auto scaling, we have seen the auto healing of the of those pods. So this is the architecture of the complete web application. You can do a two-tier application where you can run the application in one EC2 instance and you can deploy the Kubernetes and you can push the Docker image in another EC2 instance. So in the upcoming videos, I can create that, but this is the complete architecture where we create a .NET Web API application, we push the to GitHub, then we create an EC2 instance, we build the Docker file, we push the image to Docker file, then we create a Kubernetes cluster where we basically deploy all the packages, all the libraries for Kubernetes. Then we apply the deployment file, we apply the service file, and then we basically expose the port to an external environment where we can access our application. So this is all about how we can containerize .NET Core web application using Docker and Kubernetes. So thank you for watching. In the upcoming videos, I will be releasing more videos on AWS. So stay tuned and happy learning. And also don't forget to like the video and don't forget to share the video if you like the video. I will be putting more efforts to describe more architecture on Kubernetes, architecture on Docker. So we are going to start a new web series called as AWS CDK from maybe tomorrow. I will be releasing more videos on AWS CDK where I will be explaining you what is AWS CDK, where I will be explaining how we can create a credentials file in our PC or in our Mac or in our desktop, and how we are going to build the AWS CDK project, how we are going to push, how we are going to create a lambdas and so on and so forth. So let me know if you are any topic, if you have any topic which needs to be covered. Let me know in the comment section. Thank you, happy learning, and all the best.